Problem 73 asks us to determine the number of elements in the set A. Literally, we just need to count them. There's 1, 2, 3, 4 elements in the set A. So the cardinal number of A is 4. Problem 75 asks us to list the number of elements in C. Well, we count how many things are inside C, and we find out that there is absolutely nothing inside C. Notice I'm not saying 0 is inside C. If 0 was inside C, if there was a number 0, then this would be a 1. 75 would have an answer of 1 because there would be one element. So the number of elements in the empty set is 0. There's nothing in there at all. In problem 81, we're asked, do these have the same number of elements? Are they equivalent? Do they have the same cardinal number? Those are all equivalent questions, and the answer is yes, they both have 4 elements. So we could say yes, the cardinal number of A, the number of its elements is 4, and that equals the cardinal number of B. And so, yes, they are equivalent. So in part A, we're asked to write a description of the sets of A and B. Well, the set A is an infinite set, but it's kind of a wholesome infinity because we can sort of list them. 3, 4, 5, 6, ... We can use that ... because there's a pretty obvious pattern. In part B, it wasn't specified what kind of number x is, so it could be anything. It could be a counting number like 3, 4, 5, 6. It could be a decimal, like I've listed some of these decimals, 2.013. It could be the square root of 5, which is an irrational number. It could be pi, which is an irrational number. It could be transcendental numbers or imaginary numbers. It could just be almost anything, and there's no way to list this infinite number of things in any kind of reasonable order that we can think of. And so here, this infinity can be listed pretty well. Here, this infinity defies listing. I've already done part B in my answer to part A. Part B, the answer is that set B includes numbers like 2.1. Set B has an element, well, let me erase that. 2.1 is an element of set B, and 2.1 is not an element of set A. So set B includes set A. It has all the numbers that are in set A, but it has a whole bunch of extra numbers. Set A in roster form. It's infinite, so I better set up a pattern. I think I've done that. I think it's pretty obvious what the pattern is. And so that's roster form. Part D says, can we set this up in roster form? Can we set B up in roster form? And the answer is no. We can't. We don't want to. It would be awful to try. And it's not because there's an infinite number of numbers. It's because there's no pattern, there's no order, there's no way to use a ... that we can think of. So we're going to put no. Because even if there was, we wouldn't want to know about it.